Hi guys, in this video we'll be discussing parallel lines and transversal lines. My name's Roland and I'm your tutor. So parallel lines are always the same distance apart and they are denoted by arrow symbols as shown below. So if you have a look at the line AB and CD, you see that there's a single arrow. If you look at NM and OP, you've got two arrows. I've denoted this by using a red, and for A, B, and C, D, I've used green. Now we write MN is parallel to OP, and AB is parallel to CD. As you can see below, there we have it in purple and blue just to denote the letters accordingly. Now a transversal line intersects two or more parallel lines. In the diagram below, you will see exactly what I'm talking about. So you look at AB and CD, there's a line that intersects two parallel lines. We will call this line EF, and we know that these two lines below A and B and C and D are parallel because of the arrows that have been denoted. Now we've got angles A, C, B, and D from a previous video that you would probably need to go and watch. It's called the Euclidean geometry. You'll see that vertically opposite angles would be AC, and adjacent angles would be the likes of A and D or B and C, and there's multiple others. Right, as this following continues, we see that you've got EG and FH. These are vertically opposites. You've got an acute angle, the likes of G and C, and upon this we will build further rules. Adjacent angles like H and G share a common vertex and a common side. Now we'll be drawing a table to explain all the different types of angles and relationships between angles that come into play in a further state of Euclidean geometry. Now if you learn these rules correctly, you'll have a real easy time with geometry, and you won't have to stress too much when tests come about because you know all the rules, and it makes your life a hell of a lot easier when trying to complete questions. So let's jump right in. We're going to look at the name of an angle. We're going to call it the interior angle. Right, so interior angles have a certain definition. We'll put our star there to just separate between name of angle and definition. We say that the definition of an interior angle are angles that lie in between the same set of parallel lines. These angles always add up to 180 degrees, so just make a note of that. And for example, you will see that the angle A, make sure to use the little hat, and the angle F are, and the likes of G and B are interior angles. Alright, A, F, G, and B, because the lines AB and CD are parallel, and these angles are generated by the transversal that crosses the two parallel lines. Take notes of interior angles. Let's move on to the next. Alright, let's look at exterior angles. So we've looked at the interiors above. What do you think the exteriors will be? Well, there's our star, and let's move on. So an exterior angle is an angle that lies on the outside of two parallel lines. Hence the name exterior. Makes sense. So we have angles that lie outside the parallel lines. Parallel lines, there we go. The likes of which would be anything besides A, F, B, or G. And just to make note, just take note that when I draw two lines like that, as I've mentioned in red here, it means parallel. So what do you see? We've got the A, the B, the F, and the G. So the remaining angles circled in green are the exterior angles. Let's draw a star. So we have the likes of the angle C, the angle D, the angles E and the angle H, all denoted with the little hat on top of them to make sure that the reader or the teacher that's busy marking knows that you can see that that's an angle and not a side. So exterior angles, as the word exterior means, outside means all angles on the outside of a pair of parallel lines. Interior angles are all angles that are on the inside of parallel lines. Nice and simple. So let's move forward. Now in yellow, we will do the first of our rules. We'll do corresponding angles. Now, corresponding angles are angles on the same side of the transversal. So, when you have AB and you've got CD as your two lines that are parallel, you then have the transversal that cuts them up. You'll see that you've got these corresponding angles that stay on the same side. So if the lines are parallel, the corresponding angles are on the same side. I'll give you a nice example now to illustrate exactly what's being said over here. Now you see that sort of L that's over there? That is a very easy way to represent the word angles. So, corresponding angles will always be equal. And as I said, just take note that that L-looking sign actually means angle. It's a shortening in mathematics just to help speed up time during your tests and exams. It's always good to use a little bit of mathematical jargon and colloquial terms such as the parallel sign that I've mentioned above. So let's look at our corresponding. You've got A, B, C, D. These are two parallel lines. They are being cut up by a transversal, and you now see that you've got these two yellow circled letters. Those angles are called F and D in this particular case, denoted with the hat. And as you can see, I've drawn something that looks like an F. So we have the angle F and the angle D. Because they are corresponding, they will need to be equal. They're both on the same side of the transversal line, and for this to be true, the two lines that the transversal is cutting through need to be parallel. I'm just reiterating this point to make sure that you always understand exactly what's going on. As you can see, there's my sort of F shape. It's kind of bent over. Depends on the angle at which the transversal cuts through the two parallel lines. You've got the letter D and the letter F, which represent the angle F and D. As we've mentioned below over here, we see that the angles D and F are actually equal, and you can see I've got an F over there. Now if the F is perfectly straight, we will have a 90-degree angle in both of the angle spots. So you can see where I've done these sort of circles within the F. Those should represent a 90-degree. However, in our case, we have a bent over F, which means that the angles will not be 90 degrees. However, we will calculate them when asked to do so in a test. Just make sure that you recognize the F. It's very important. There are three rules. This is the first of them. So we have corresponding angles, and these are angles that are on the same side of the transversal and they're equal. Make sure that you understand your definitions. This section of geometry is very much a learning section. Now let's move on to our purple, our co-interior angles. Our co-interior angles are relatively similar to the previous set of angles that we discussed. The previous we did F, and this we will use a U or an N in some cases, depending on the angle at which the transversal cuts through the parallel lines. So co-interior angles are angles that lie between the lines and on the same transversal or the same side of the transversal and they sum to 180 degrees. So if you had a perfectly perpendicular transversal to the two parallel lines, you would have two 90 degrees that are co-interior. 90 plus 90 is 180 degrees, and hence we say the co-interior angles are equal to 180. So if the lines are parallel, then the angles are supplementary. Now if you remember, and if you don't remember, then you should go watch the previous video called Euclidean Geometry. But if you do remember, well done for watching that video. Supplementary means 180 degrees. Two or three angles, or angles that are adding up to 180 degrees. The other term would be complementary, and complementary would be 90 degrees. So angles that sum together to make 90. Now as you can see, I mentioned earlier that you use the letter U or the letter N depending on how you are looking at it. So there's our co-interior. We can even use a letter C to make sure that we understand that it doesn't really matter upon the shape. It just matters the fact that we see that the co-interiors look like a C. So you have the angle on each side there. There we go, we'll do it in purple. So this is kind of a skewed off C. If you turn your head to the side, it can look like a U, or if you turn your head to the other side, it can look like an N. Now as you see, G and that B both sum to 180 degrees. If you're to straighten up that C, you would see that you get a 90 and a 90, and that's the way to prove co-interior angles would be supplementary. Now at this level of maths, that's not very important. You haven't probably gone through that in school. However, it is important to note for your own understanding of the concepts. So we say the angles B and G are equal to a 180 when added together, and that's only if the lines are parallel. So if you ever get asked in a test, show the co-interior angles, make sure that the lines that you are looking for, or the angles that you're looking for between the parallel lines need to be parallel. If they're not, then simply state that the co-interior angles are not in fact co-interior, due to the fact that they do not meet the requirements of parallel lines. So let's move on to our third type of angle here. We have alternate angles. We have the equal interior angles, and the shape that we would be looking for would be the letter Z. So what you can take into account is that the angles would be vertically opposite in a sense. However, they are not really vertically opposite, but they do share the parallel lines. You would find that the turn of the Z would be the angle 1, and the turn of the bottom, so that would be the top turn of the Z. The bottom turn of the Z would be the angle 2. And these two angles would be equal. So they are both on the opposite sides of the transversal. The angle between the transversal and the parallel line at the top, and the angle between the transversal and the parallel line at the bottom, are therefore equal. So if the lines are parallel, then the interior angles will be equal as well. Please understand that this is a long sort of written video, so the speech will be a little bit slower than usual other videos. But as you can see, within the bending action of the parallel line and the transversal, you'd find your angles. And it looks like a Z. There you go. We'll show this on the diagram above shortly. Just make sure that you take note of the alternate angles and the rules that follow it. Here we go. Back to our diagram, we can see that the letter, or the angle A and the angle G are in fact equal, as they are alternate angles. And there's our Z shape that we discussed earlier. We'd have the A and the G being equal. They share the same transversal. They are interior angles. They're acute. and they form the Z shape that we were discussing for alternate angles. Alright, over here we see that our examples would be the angles A and the angles G. We see that A and G are alternate angles, and they make sure to fulfill the Z shape that we described earlier. Right, let's do a little bit of recap. We made sure that we did 3 rules. We started off by using the corresponding angles, and if you can remember correctly, that would be which letter? That's correct, the letter is F. The transversal slices through the 2 parallel lines and causes the 2 corresponding angles to be equal. We then did the co-interior. Co-interior is either the C, the U, or the N, depending on what you like to use. There we go, we have co-interior angles equal to 180 degrees, otherwise known as supplementary. And then we have the alternate angles, which look like a Z or an N. So if you ever forget it, you can look at that and you could say, flip the co-interior to the left and say it looks like a U, and do the same for the alternate and it would look like an N. So the rule would be fun. You have corresponding, co-interior, and alternate angles. Please take note of this. It's very important for your geometry in the future. Very, very, very important. Make sure to remember it. So just remember, F-U-N, corresponding, co-interior, and alternate angles. Now, if 2 lines are intersected by a transversal line, and such that the transversal cuts through the parallel lines, and we see that corresponding angles are equal. As I mentioned before, study this section very hard. It's a lot less practice rather than a lot more rules to learn. Now, the alternate interior angles are in fact equal. Now, with that said, we will move to our third point. We say that if 2 lines are intersected by a transversal such that the corresponding angles are equal, or the alternate interior angles are equal, or lastly, the co-interior angles are supplementary, meaning that they sum to 180 degrees when you add them together, you'd say the angle A and the angle B, if they're co-interior and they add up to 180, they are supplementary. Now, if we meet any of these rules, then those 2 lines are parallel. Look at that, how you've got the 2 L's. That's where we actually get the short sign of the L and the L together. So take note of that. I hope you've enjoyed this video. Easy game.